All right, so here is problem 4 of homework 6. In this one, we're given some mechanism where there's like a sliding collar on this rod here, and then it's loaded up at the top with this P force, and we are tasked to find a couple that will hold it in place about D here. And if we read through this, it tells us it wants us to find that couple M required to hold it in place. And then it also says that theta is equal to 0 degrees, which simplifies things here. And then it gives us P is equal to 240 newtons. All right, so to get started, I'll draw the free body diagram for the ABC member. So I'll start with coordinates, X, Y, positive moment. And then we'll do just the CA linkage here, and then somewhere in the middle there's B, and then it gives us these measurements, 0.16 meters here, and then from B to A it's 0.09 meters. I'm just converting it to meters for ease, and then up here we have 0.32 meters. And then from B to A on the Y direction is 0.18 meters. Okay, and then so we are given this P value here, and we also know that the theta is actually equal to 0. So this will just apply along the x-axis right here at A. So we can draw P like that. And then the collar here is sliding along this way, so it's not going to supply any constraints along the x-axis. It will, however, supply a constraint along the y-axis, and then you may think that it will cause a moment as well, a moment reaction, but since it is connected by this pin right here, it actually doesn't restrict moment around that pin. So altogether, it will only have a Y reaction force. So we can draw that in right here. We'll call it BY. And then at C, we have a pin. So that will have both X and Y reaction forces. So we'll have CY and CX here. And then from this, we have all we need to solve for these forces. We have 3 unknowns, and it's a 2D problem, so we can solve for that. We'll start with sum of forces in the x direction is equal to 0 because we only have Cx and P, so that would be a quick one to solve for. If you just rearrange for Cx, you get that Cx is equal to P, which is given as 240 newtons. And then from there, if we do a moment balance about C, we are able to ignore CY and CX for now and just focus on BY, which is helpful. So we can go do that. So BY is going to be in the clockwise direction, so it'll have a negative value, and P will be in the counterclockwise direction, so it'll have a positive value. So P will have this 0.5 meter moment arm, which is the sum of these, and it's positive in the counterclockwise. And then BY is going to have this 0.16 meter moment arm in the negative direction. And then if we rearrange for BY here, we can find that that is 750 newtons. And then now we have enough information to do a sum of forces in the y direction. So we are looking for CY here. We have CY minus BY. And then that is it. So if we rearrange, we get CY is equal to BY, and that is 750 newtons. All right. And now, if we draw the free body diagram for the CD member, we can transfer over these CY and CX values and use those to solve for that. So we'll do that over here. So CD member. So we'll start at C, go up to D up here. And then the forces on this are the pin reaction forces, but actually they have to be in the opposite direction because they're Newton Newton reaction pairs, so they're equal and opposite. And then we also have this moment at D. Then there's also the D reaction forces, dy, dx. And what we can do is we can take the moment about D, because we know that will cancel out dy and dx, and then we know both of these. So the only unknown we have in that equation is this m. So if we do that, we have moment about D is equal to 0. And then this couple is in the counterclockwise direction, so it's positive. And then we have cy in the counterclockwise direction with, forgot to draw it out, but we have this distance as 0.3 meters. And then this distance up here is 0.125 meters. So we can do plus this 0.3 meters times cy. And then this is in the clockwise direction, so it'll be negative. So it'll be minus 0.125 meters cx. And we know these values, so we'll just plug those in here, rearrange for m, and we get that m is 195 Newton meters. And there you go. And it would be, it would actually be negative in the counterclockwise direction. And so that is problem 4.